Hi, my name's Nico, and for my capstone project this year, I undertook a project to alter the chip sealing methodology. Chip seal plays a significant role in the roading infrastructure within New Zealand. Currently, over 62% of New Zealand roads are covered in chip seal. Each summer, roading contractors seal thousands of kilometres of road, and each summer the media covers issues about risks to public health and damages to private vehicles. Currently, chip seal is constructed by spraying a uniform layer of bitumen on the road surface. This is then followed by the application of an excessive amount of aggregate. This is in the hope that 90% of the aggregate will adhere to the road surface. The excess chip is left on the road while the bitumen can cure. During this time, it is common practice to use public traffic to aid in the compaction of the chip seal. It is during this time that there is significant risk to road users who might be obstructed by projected aggregates. The excess chip is then removed from the road, often swept into the shoulder, leaving behind a finished chip seal surface. Reducing the excess aggregate on the chip seal surface has need for further development. By doing this, it will keep public and their vehicles safer and minimise wasted aggregate in the process. It was found that currently there is development into polymer modified bitumen and pre-coated aggregate. Polymer modified bitumen looks to optimise the adhesion between the aggregate and the bitumen, but more importantly achieve the adhesion in a short time after application. Similarly, by pre-coating aggregate in a light bitumen layer, this achieves earlier bond strength than the use of regular aggregate. It is hypothesised that the use of these developments, instead of applying aggregate in the hope that 90% of it will adhere, the application rate can be reduced so that in the hope that 95% of it will adhere. This project aims to develop a method that can better determine the aggregate application rate. So once these developments are better implemented into roading projects, there is less harm to motorists. However, there are numerous chip seal designs incorporating different combinations of aggregate to best suit the location. Therefore, this project investigates a method to determine these application rates. The distribution rate investigated in this project is for a grade 5 chip. This is commonly used as the top layer of a road surface, and therefore poses the most risk to public. The application rate is measured in the amount of square metres 1 cubic metre of aggregate can cover. The application rates tested are from the New Zealand Transport Agency Chip Sealing Manual. Interestingly, they document an old application rate and a new application rate. The new application rate almost doubles the old. A theoretical application rate was also investigated, and in addition, a 5% increase from this rate. After investigation into potential chip sealing testing methods, a violet test was discovered. This test is the best fit as it will help find the distribution rate where the aggregate retention is optimised while still upholding a standard of chip seal. There is existing research using the violet test, as well as standards outlining the procedure to conduct the test. The violet test involves dropping a 500 gram steel ball from a height of 500 millimeters onto the back of an inverted chip seal. This aim is to complete 3 drops within a 10-second interval. The aggregate retention can then be measured. Several alterations had to be made to the violet test due to time constraints. These being an alternative roller, an alternative ball, alternative sample trays, and the use of a different bitumen product. All these alterations were justified to have minimal effect on the results. It was found that the current NZTA distribution rate achieved 94.3% retention, while the old distribution rate achieved 99.2% retention. The theoretical distribution rate achieved 98.7%, while the 5% increase of the theoretical retained 98.5%. Visual inspection of the chip seal was an important way to determine the quality of the chip seal. A reference was found in the NZTA Chip Sealing Manual as an optimal chip seal finish. Without enough aggregate, this presents further problems, such as loss of skid resistance. It is found that the 5% increase of the theoretical application rate produces a high quality finish and only lost 1.5% of the aggregate. The results achieved in this experiment proves there is an optimal application rate. With further investigation, this can be determined, along with the distribution rate for each chip seal design. Thank you. I hope you enjoyed this presentation.